Okay, we're now recording. And share the screen. Like that. Okay, we'll take a look at our calendar. So far, we're pretty much keeping along with the calendar. So today, 3.6 and 4.1. And I'll do 4.1 tomorrow also. And tomorrow you'll have your next quiz. Okay. The quiz will be on combining functions like last time. So composition of functions, stuff like F circle G, G circle F, I'll give you that. And maybe adding, subtracting, multiplying, dividing functions, okay? So I'll give you two functions like F and G. Maybe I'll ask you to add, subtract, multiply, and divide the functions. That's pretty easy. The harder one is to find the F circle G, F of G, or G of F. Okay, so I'll give that to you tomorrow. As usual, that'll be at the end of class. I'll put you in the breakout groups of 3 or 4, and you work on it together. And Star will come around to different breakout rooms to see if anybody needs help. Most of the time I'll be in the main room, but I might want to visit your breakout room possibly. But Star will do most of the going around from room to room. I will mostly be in the main in case you want to catch me in the main. Okay, just like all the other quizzes, put your first and last name, put the first and last name of everybody else in your breakout room. And your object is to get the questions right, of course, and then get all your teammates to get it right. I will look at all the quizzes, but I only grade one of them. So since you don't know ahead of time who I'm grading, to be sure that you get full credit, make sure everybody in your team gets it all right. Then it doesn't matter, of course, who I picked, and you'll get full credit on the quiz. Okay, and then that would be that. And remember, we have a 4-day weekend coming up. We don't meet Fridays anyway, but if you have any other CSM classes on Friday, Friday's a holiday, Monday's a holiday, have a good 4-day weekend. We will meet again on Tuesday after that. Okay, so that's what's happening. So 3.5 is 1 to 17 odd. I'll do some of 3.6 also, which is 5 to 15 odd. It doesn't look that long, but it's longer than you might think, as you might expect. And sometimes, there's part A, B, C, D, and so on. Okay. Let me check the chat real quickly. Okay. All right. If anybody wants to answer that, you may. But here we go. Okay. So let me get started with 3.6, which is on something called inverse functions. Now, you should have seen the concept of inverse functions before in your intermediate algebra. If you're following along the book, I'm on page 194. Inverse functions. Okay, so first off, on page 195, we have a definition of something called a one-to-one function. A function is one-to-one. You can also write one-to-one like this, 1-1. I like writing it this way. It's shorter, of course, as opposed to O-N-E-T-O-O-N-E. A function is one-to-one if each element in the range of F comes from a unique element in the domain of F. Okay? So for a function, I'll write it in my book. For a function, 1x can only give you 1y, you might recall. Okay? If you have a function and x can only give you 1y, for a one-to-one function, the other way around also. 1y can come from only 1x. So 1x gives you only 1y for a function. For a one-to-one function, 1y can only come from 1x. That's going to be called a one-to-one function. And give you some examples. Okay, for f of x equals 4x minus 7, it's a straight line, mx plus b. It happens to be one-to-one. Okay. If I put any y value, you can solve for x, right? So suppose I said y, remember y is f of x. Suppose y is, 3. You can solve for x. And there's only going to be one possible value of x. That will be considered one-to-one. not one-to-one is this one, okay, and there's a reason for that. By the way, the graph is a parabola. X squared minus 4x plus 3, we've seen that, that's a parabola. It's not going to be one-to-one because it's possible to come up with a y value where more than one value is satisfied. Okay, let me go back to this. Suppose I say y equals 0. X squared minus 4x minus 3 equals 0. Oops, plus 3. That can factor into x minus 1, x minus 3 equals 0, which means x equals 1 or x equals 3. So I have a particular y value, 0, which has two possible values of x. Okay. So that means that we do not have a one-to-one function. Okay. So for one-to-one, if you give me any y, there's only going to be one x. Okay. If I say y is 10 or 20 or pi or a million, you can solve for x, there's only going to be 1. Here, I could have a y, the easiest one is to say y is 0. There's two possible values for x, which means we do not have a one-to-one function. Okay. Now, inverse functions, page 196. If you have a one-to-one function, you have something called the inverse function. Okay. What does the inverse function do? The inverse function kind of undoes the function. It's the undo function. Okay. It brings you back to where you were. Okay. You have a picture here. Okay. So domain of f. Okay. So you have a function going this way. The undo function, the blue function, goes back. Okay. We write it as f inverse. See that f with a -1 there? That's read as f inverse, inverse function. Okay. So if I have a function x going to y in red, if it's a one-to-one function, you can go backwards. Okay. There is a function called the inverse function, which has you go back. You're just basically switching it back and forth. So that means the domain of f ends up being the range of the inverse function and vice versa. You're just switching around the x and the y, as it were. Okay. So x goes to y, then the y goes back to x, if you have something called an inverse function. Okay. The notation we use is, it looks like f to the -1 power. See that f with a -1? But we say f inverse. Okay. F inverse. F inverse. All right. So here are properties of the inverse function. This is on page 197. Of course, you're welcome to put as much or as little as you want on your next cheat sheet of any of this stuff. You say, I don't know what's going on. I better write it down on my formula sheet. Yeah, you're allowed to. Okay. Anytime you compose f with f inverse, either like this or like this, you get back the original. So f of f inverse of y is y. F inverse of f of x is x. You can have any letter that you want here or any number. Okay. So when we're doing composition of functions, right, the f circle g and g circle f stuff, okay, anytime you have a function composed with its inverse, you get back the original. So let's say this was 2, this is 2. If this was 7, this is 7. Anytime you have f followed by f inverse, or the other way around, f inverse of f, as long as you're in the domain of the function that for which it's defined. Okay. So a function composed with its inverse always brings you back to the original. Okay. How can you tell graphically if you have a one-to-one function on page 199? Okay, so the horizontal line test. Now you've heard of the vertical line test. We now have a horizontal line test. A function is one-to-one if and only if each horizontal line intersects the graph of y equals f of x in at most one point. So look at examples A and B. Raise it up a little bit, but bring it back down. These are both functions. They both pass the vertical line test. Right? If I draw a vertical line anywhere, it's going to touch at any one point. This one is a one-to-one function. If I draw a horizontal line anywhere, it's going to touch at any one point. B, however, is not one-to-one because it's possible to draw a horizontal line which touches at 2 points. Okay, so it fails the horizontal line test. Okay, so both of these are functions. They both pass the vertical line test. Okay. A is considered a one-to-one function. It may not be obvious from there, so this is considered one-to-one. This is not one-to-one. Okay. If I draw a horizontal line anywhere, this one will touch at only 1 point. This one, it's possible to touch 2 points. So it's still a function. It's just not considered a one-to-one function. How about a straight line? F of x equals 2x plus 1. This looks like it's one-to-one. Passes both a horizontal and vertical line test. Okay. Now, some properties of the inverse function that I'll show you. Figure 5, page 200. Here's a function and its inverse. Maybe we'll look at this one. These are really the same except for this other one here. Okay, f of x equals 2x minus 1. There is an inverse function. They told you what it is. How do we get it? I'll show you. But essentially, you just switch around the x and the y. Okay, so look at this function. 1, 3, switch it around, 3, 1. 0, 1, switch it around, 1, 0. Negative, can't even read it. Negative a half, 0. 0, comma, negative half. So you just switch around the x and y values. And you end up with that. Okay. Here's the formula for the inverse. Well, if you switch around the x and y's here, you're just going to switch around x and y here. And I'll show you how to do that. What they're trying to show you is that there is a symmetric property. The two inverse functions are symmetric about the line y equals x. Okay. So remember we talked before about y-axis symmetry and x-axis symmetry. Here we have symmetry about the line y equals x. Y equals x goes through the origin up at a 45-degree angle. Okay. So you have a symmetry about the line y equals x for inverse functions, like so. We're trying to show you figure 6 also. Okay. So y equals x is right here. So look at the two red graphs. They are inverse functions. So if you reflect one of them across the other, then you get the other one that's there, figure 6. Okay. So you have symmetry about the line y equals x. Okay. A little bit more to emphasize it. Page 202. Okay, so look at the line y equals x. The original graph, y equals f of x in blue. They give you a point A, comma B, right? So if you reflect across the line y equals x, you have the point B, comma A in the inverse function. Okay. Notice both functions are one-to-one. The inverse is also one-to-one. Now, if you had a function which was not one-to-one, it would not have an inverse. The inverse would turn out not to be a function. Okay. This is one-to-one, right? Passes both the vertical and horizontal line test. So the inverse also passes the vertical and horizontal line test, as you can see there. Okay. All right, so I'll show you how to find the inverse function and do some problems. I do see some stuff in the chat. So let me check the chat quickly. And I think it was just something about a textbook. Okay. So thank you, Yumi. And anybody who wants to see that in the chat, you can. Textbook. All right. There. Okay. So let's do some of the problems. We quote unquote only have 5 to 15. But again, it's not that short. It has parts A, B, C, D, and all that kind of stuff. Problem 5 is not really that hard. Okay. So 5, let f of x equals x cubed plus 2x plus 1. They really don't even have to tell you that. Assume that there is an inverse function. The domain is all real numbers. Simplify each one. Okay. So if we look at 5, I don't think I'm going to write anything. In each case, look at 5 A, B, C, and D. We have f and then f inverse for A. Same thing for C. You see that circle, f circle, f inverse? That's the same thing. B, they have f inverse of f. D, they have f of f inverse. It doesn't matter. Anytime you have a function immediately followed by its inverse, you're back to where you started from. Which means the answers automatically are A is 4, B is -1 going down, C is square root of 2, and D is t plus 1. That's all there is to it. There's no work. It's just knowing what the inverse function does. Okay, so again, anytime you see f of f inverse or f inverse of f, it doesn't matter. You just get the same thing back. So again, the answers are A is 4, B is -1 down here, C is square root of 2, and D is t plus 1. That's all there is to it. Okay. So that was kind of too easy, frankly. So do one that's a little bit harder. Okay, so 7 and 9 are similar. Okay, I think I have time to do both. Let's try 7. G of x is 2x plus 5. And they ask you questions, and so that's okay. Let's go for it. So 7. Show that the inverse exists. Okay, if they give you g of x, f of x, whatever, call it y. Okay. Now, in the examples I showed you, we switched around the x and y. We're going to do that over here. So switch x and y. That means anytime you see x, put y. Anytime you see y, put x. That's x equals 2y plus 5, right? Switch around x and y. And then just resolve for y. It's not that hard, right? So they give me g of x, write it as y. Y equals 2x plus 5. Switch around x and y. Solve for y. So subtract 5. Divide by 2, right? Okay, so y is equal to f inverse of x. Now I want you to get used to writing f inverse of x. Okay? Now if I give you a question like this later today, it's kind of hard to type this, right? So you don't have to write this for me when you're just typing on your keyboard. But when you're writing in a homework and quiz and test, I want you to write the f with a -1. It means the inverse function. Okay, so x minus 5 over 2. That's the inverse function. Okay, so the inverse exists. So I'm doing A and B. Give the domain and range of G inverse. Okay, this is a line, right? Very crudely, it looks something like that. So domain and range is all real numbers. So F, domain is all real numbers. Range is all real numbers. Okay, so let's distinguish between these two. The regular looking R, if we know we're talking about domain and range, that's for range. The funny looking R means all real numbers. Okay, and we know D is for domain. For F inverse, you switch around the domain and range, but it's still going to be all reals. Okay, so F inverse, domain is all reals, and the range is also all reals. Okay, let me uncurl it again. It tends to curl up on me. Okay, so again, to find the inverse, if they don't give me a y, call it y. Switch around the x and the y, then solve again for y. So subtract 5, divide by 2. Write it as f inverse, but later on today, if I ask you one of these, you don't have to write the f inverse, just give me the function, as it were. Okay. Calculate C. G inverse of 3 and 1 divided by G of 3, are they the same? Okay. So G inverse of 3 means I put 3 into the inverse function. 3 minus 5 over 2, which is negative 2 over 2, which is negative 1. They also ask for 1 over G of 3. So 1 over 2 times 3 plus 5. That's 6 plus 5, 11. So 1 over 11. Are they the same? No, they're not equal. Okay. They're trying to emphasize that G with a negative 1 does not mean 1 over G of 3. Okay. This is an inverse function now. So that negative 1 is not an exponent. It's a new symbol, which means inverse function. So in other words, don't confuse this with this. Okay. G inverse of 3 is not the same as 1 over G of 3. Okay, then part D, they want you to do the graph stuff. Graph G of x, G inverse of x, and y equals x on the same set of axes. Okay. So how am I going to do that? Okay, so it's the easiest way I'm going to do that. I know how to graph that from before, y equals mx plus b, right? Okay, so what's the y-intercept? 5. So 0, 5, 1, 2, 3, 4, 5. 0, 5. Slope is 2. Means over 1 and up 2. Over 1, up 2. Gives me 1, 7. And do you recall from your earlier work, is that good enough to graph it? Right? You only need 2 points if it's a straight line. So just connect it. So there's F. Y equals mx plus b. Where'd it go? Right? The b is 5. Y-intercept is 5. Slope is 2. 0, 5, over 1, up 2. Now, for the inverse, I could plot points and make that look like y equals mx plus b. It's a little bit clumsy. There's absolutely an easier way to do that. Okay. Remember, for the inverse, you get to switch around x and y values. So why don't I just switch these around? Okay, I guess I need to mark off some more here. Let's go farther out. So what do you get when you switch around 0, 5? 5, 0. 1, 2, 3, 4, 5. 5, 0. What do you get when you switch around 1, 7? 7, 1. 1, 2, 3, 4, 5, 6, 7, 1. 2 points determine a line. Connect them. And there's F inverse. Okay, and they also ask you to graph the line y equals x. Y equals x always goes to the origin and goes up at a 45-degree angle. So here we go. Okay, so the reflection of the black line across the line y equals x is the red line. Okay, so if you imagine putting a mirror right here, right, then the black line would reflect over to the red line. So that's the idea. All right, try another one like that. Okay, number 9. F of x is equal to 1/3 x minus 2. Okay, so find the inverse function. So call it y. Switch x and y. So every time you see x, put y. Every time you see y, put x. And then resolve for y. So how about add 2 to both sides? Plus 2, x plus 2 equals 1/3 y. How do I get rid of 1/3? Multiply by 3. Right? So y equals f inverse of x, f to the minus 1 of x, f inverse of x is 3x plus 6. And there we go. Now, a little bit harder. Yeah, it's a little bit clumsy. Even though it's problem 9, they tell you to follow directions for 8. Okay, so find f inverse, give the domain and range of f inverse. Okay, so it's all real numbers. These are both straight lines. So domain, all real numbers, range, all real numbers for both f and f inverse. Now, however, verify that f of f inverse, 9c, which is really 8c, verify f of f inverse is x, and f inverse of f is x. Okay, that's like the composition of functions. Okay. So f circle f inverse of x. That's like the f of g. Remember the fog or the Goff, f circle g, g circle f. And we said in general that they were not equal. In this case, they are going to be equal. F circle f inverse and f inverse of f will always be the same, and you're always going to get back x. Okay, so let's try it. So f of f inverse, I now know this is the inverse function. So this is like the other day, right? So f inverse is that. Now this thing gets applied way back up to here. So 1/3 of the junk minus 2. So here we go. 1/3 this junk minus 2. Okay. So whatever's inside the parentheses goes right there. Okay, clean it up. 1/3 times that is x. 1/3 times 6 is 2 minus 2, and that's equal to x. That's what we were trying to show. Okay. The double lines actually mean something in logic. It means end of proof, or that which was to be shown. I've proven what we were trying to prove. Okay. I won't mark you off if you don't put it, but that's a way of saying end of proof. Okay, now I have to go the other way, f inverse of f. F inverse circle f of x. Right, we're composing functions. Remember in general, when you did f of g and g of f, the one that looks like fog, was not the same as the one that looks like golf. Okay? They, in general, weren't the same. Here they are going to be the same. And even more specifically, it's always just going to be x. Okay, f inverse of f. So f is this, 1/3 x minus 2. Okay. And now this mess is going to go into f inverse, which is right over there. Okay, it's 3 times the mess plus 6. Okay, so here we go. 3 times the mess plus 6. Okay, so let's distribute. 3 times 1/3 x is x. 3 times a negative 2 is minus 6, plus 6. And yes, we also get back the original x. So that proves that they are inverse functions of each other. They undo each other. Okay? It's like when you do the undo on your keyboard, on your computer application, right? You know, sometimes you make a mistake. So, oh, I didn't really want to do that. Can I get back to where I was? Right? That's the inverse operation. All right. And then once again, they ask you to graph the function and its inverse on the same set of axes. Okay. So no big deal. 6, 7, 8. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Actually, maybe I have to go out to 9, come to think of it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So how did you know I was supposed to go out to 9? Well, I saw the 3 and a 6, right? So if they touch at 6, I'm going to have to go up 3. So I went for an extra 9. Okay. Let's see. Slope is 1/3. Y-intercept is negative 2. So 0, negative 2 is right there. Slope is 1/3, which means over 3, 1, 2, 3, and up 1. I'm going to do it again, over 3, up 1. You can do it as many times as you want. That's good enough. So this is 0, negative 2. That is 3, negative 1. That is 6, comma 0. Looks like, right? I go over 3, up 1, over 3, up 1. 0, negative 2. 3, negative 1, 6, 0. 0, negative 2, 3, negative 1, 6, 0. Okay. Play connect the dots. And there's the original f. Okay. Now the inverse. 3x plus 6. Now I can do the slope and y-intercept. You know, that works. But let me just do the concept of switching around x and y. Right? So 0, negative 2, switch it around. Negative 2, 0. 3, negative 1, switch it around. Negative 1, 3. 6, 0. 0, 6. 1, 2, 3, 4, 5, 6. There's my inverse. Negative 2, 0. Negative 1, 3. 0, 6. And draw the line y equals x. Again, that always goes through the origin at a 45-degree angle. So we're just going to go like this. X. Okay. Again, the mirror image of f is f inverse and vice versa. So if I reflect across the line y equals x, then I get the other one. Okay, so that's what we have there. Okay, I think I'll show you 11, which is kind of interesting. Show you the directions. Follow exercise 8, but use f of x equals 1 over x. Now, that's one of our basic functions, right? It's a reciprocal function. Well, let's just do it. Switch around x and y. Solve for y. How do you solve for y? Well, I can multiply both sides by y. Divide by x. One over x. Which is the correct answer, but do you notice anything about that function? Same as the original. So here's an example of a function which is its own inverse. F of x equals 1 over x is its own inverse. There are several functions which are their own inverses, but if you stop and think about the meaning, it makes sense. 1 over x is reciprocal, right? So if you take a number, find its reciprocal, and then do another reciprocal, you're back to where you started, right? Like take 7. What's the reciprocal of 7? 1/7. Now reciprocate again. What's the reciprocal of 1/7? You're back to 7. That's true for any real number, right? If I start off, let's say, negative 2/3. Take the reciprocal, flip it, negative 3/2. Flip it again, well, get back to where you started from, right? Negative 2/3. So this function is its own inverse. Okay. We've already seen the graph before. I'll just show it to you again. It's probably a good idea to memorize this quickly. That's the graph. Okay, asymptote, asymptote. We need to tell that x cannot be 0, and therefore y cannot be 0. So the domain is all real numbers minus the set consisting of 0. And the range is also the set of all real numbers minus the set consisting of 0. Right? So it's kind of a cheap example, so to speak. So that's that. And then they say find f of f inverse. Okay. So f of f inverse of x. Well, since they're the same function, it's f of 1 over x. And now I reciprocate 1 over x, which means 1 divided by 1 over x. Okay. But remember, if you divide by a fraction, if that looks bad, if you divide by a fraction, you multiply by the reciprocal, right? So dividing by 1 over x is the same as multiplying by x. And there it is. And you don't really have to do f inverse of f because you just did it since they're the same function. Okay, so in other words, f inverse of f of x is the same thing. It's the same math as you would have here. Okay, so I'm actually done with this. It's faster than you might think. This is f, and just for fun, change colors. It's also f inverse. And if you stop and think about it, it actually makes sense. Let me draw the line y equals x. Okay, and maybe if we temporarily only look at this part, don't look at the whole thing. If you only look at this part in the first quadrant, right, the reflection of the bottom part is the top part, and vice versa. And likewise, now if you only want to look at this part, forget about this, right? The reflection of the top part is the bottom part, and vice versa. So yes, indeed, it is a case where a function is its own inverse. Inverse of the function is the same as the function itself. Okay. All right. Okay, that's that. Let me set you up with one more, and then after that, maybe we'll break. 15 is a little bit more complicated. 2x minus 3 divided by x plus 4. Find a domain and range. It's probably easier to find a domain and range after I find the inverse function. Okay, so in other words, I'm going to go backwards. I'm going to do C and then B and then A for this one. Okay, 2x minus 3 divided by x plus 4. X minus 3 divided by x plus 4. Okay, call it y. Switch them around. Everywhere you see x, put y. Everywhere you see y, put x. X equals 2y minus 3 over y plus 4. There's two y's this time. Solve for y. So how do I solve this one for y? Let's multiply both sides by y plus 4. Like that. So distribute. xy plus 4x. These guys cancel out. Okay. To solve for y, you want everything that has a y on one side, everything that doesn't have a y on the other side. So these two have a y, right? Get them on the same side. These two do not have a y. Get them on the same side. And I prefer to have as many positive as possible. So I'm going to add the 3, and I'll subtract the xy. I'm going to put all the y's on the right side, and the stuff that doesn't have a y on the left side. Now, can I put the y over here? And this over here? You could, but notice what happens. If I move the 4x over here, I have a negative 3 minus 4x. Okay, I don't like all those negatives. Okay. If I put the y's on this side and the non-y's on this side, it's a little bit cleaner. Okay, I would have 4x plus 3. I like that better. Right? Subtract that, I would have 2y minus xy, like that. Okay, so I added 3, subtract xy. Okay, and I hope you can follow what I'm doing. Everybody has had at least 2 algebra courses, otherwise you wouldn't be taking my class, right? So you've had 2 algebra courses minimum. So I think you know what I mean when I do this. Add 3, subtract xy. Okay, all the y's are on this side. The non-y's, the stuff that doesn't have y, is on this side. Okay, now you factor out the y. Y parentheses 2 minus x. Can you see how to isolate the y now? Just divide both sides by 2 minus x. And you got it. So y equals f inverse of x is 4x plus 3 divided by 2 minus x. Okay. So that's it. And the last thing it talks about is getting domain and range. The best way to do that is to get the domain of each of these, and the domain of one becomes the range of the other. So let's look at the original function. Domain is all real numbers except for negative 4. Right? You can't have negative 4 there. How about the domain of this one? You're not allowed to have 2. Right? You're not allowed to divide by 2. Now this part just becomes easy. The domain of one just becomes the range of the other. So I can just copy that as the range over here. So the range is all real numbers minus the set consisting of 2, because the domain of the inverse function is the range of the original function. And likewise, the range of this function is the domain of this one. So I just copy this. Range of the inverse function is all real numbers minus the set consisting of -4. So range is all real numbers minus the set consisting of -4, like so. And that pretty much does it. Okay. All right, so to find the inverse, switch around the x and y, and then resolve for y. Okay. Let's see. I think we're caught up here. Yeah. Okay. I think it's a good time to take a break. All right. So let's break right now. See, 11:57. So 12:10. Start up again at 12:10. I'll put that in the chat, and then I'll disappear also. Okay. So break until 12:10. There we go. Okay, folks, we'll continue on. So I'm done with 3.6, and on the schedule, I only have 4.1 left between today and tomorrow. So I should have plenty of time. So I'll do some of 4.1. I don't have to do that much. I'll stop and give you something to do, and we'll probably finish quite early. Tomorrow I'll finish up 4.1 and give you a quiz. And the quiz will be on combining functions. So like I'll give you f of x and g of x. You might have to add them, subtract them, multiply them, divide them, or find the composition, f of g or g of f, something like that. Okay. Okay, so chapter 4, 4.1 is a review of linear functions. Now the whole chapter is on polynomials, rational functions, and some applications. Applications are word problems. Okay. And by the way, we're not doing the entire chapter, only sections of it. So 4.1, 2, 5, 6, and 7. We're not scheduled to do 3 or 4 because we don't have to. Okay, so linear functions, straight lines, you've already seen them before. Okay, so quick review of linear functions. 4.1. So just a quick review of linear functions, straight lines. So y equals f of x equals mx plus b. Seen that before. This is the slope. This is the y-intercept. Right? In fact, we did that in some problems before the break also, right? And we know how to find the slope. Y2 minus y1 divided by x2 minus x1. Sometimes we write delta y over delta x. This is the Greek letter delta, which means change. Change in y divided by change in x. And you've probably also heard rise over the run. Okay. And we'll also have occasion to use the point slope form. We've already done it a little bit. Y minus y1 equals m times x minus x1. Right? So all of this should not be new. You've seen all of this before. Let me raise it up so it's easier to read. Right, so we only have to do, what, 1 to 19? Okay, so I'll do some today and I'll do some tomorrow. Okay. All right, so let me show you the book. Okay, 4.1, page 224. 1 to 19 odd, so there's 1 through 7, hopefully. 9 and 11, looks like we have some word problems. And we have to go up to what, 19? So 13, oh, 13 looks like there's a lot there. Got a table there, 13, 15, 17, and 19. Yeah. Okay, so it looks like at the end we have some word problems. All right, so let's start off with number 1. Find a linear function satisfying the given conditions. Okay, number 1, f of negative 1 equals 0, and f of 5 equals 4. Okay. Now these are just 2 points. Don't get scared by the notation. It's the ordered pairs negative 1, 0, and 5, 4. Okay. This is x, this is y. This is x, this is y. If you ever forget, just think, normally do we say f of x or f of y? Technically you could say f of y, but we almost always say f of x, right? That's x, y, x, y. So in other words, the line goes through these 2 points. If you just stop and think about it, if I take any 2 random points, I can draw a line through them, right? So what's the equation of the line goes through these 2 points? Okay, so first let's find the slope. So y2 minus y1, 4 minus 0, divided by 5 minus a negative 1. So that's 4 divided by 6, 2/3. Now I can use the point slope form. You have a choice of points. You can pick either this one or this one. I'll pick this one because there's a 0. I like to plug in 0. So y minus y1, which is 0, equals m, 2/3, x minus a minus 1. Okay, that's the same as x plus 1. Y equals 2/3 parentheses x plus 1. Y equals, and write it as a function, f of x, 2/3 x plus 1/3. Okay, so that's all. Check, that should be 2/3 here, my bad. 2/3 times 1 is 2/3, right? By the way, one way you can check that is if you plug in negative 1, you should get 0. And if you plug in 5, you should get 4. Check, if you plug in negative 1, it's negative 2/3 plus 2/3, that's 0. Plug in 5, there's a common denominator. So 2 times 5 is 10, plus 2 is 12. 12 divided by 3 is indeed 4. So it works. Okay. Seven, I'll come back to 5, but 7, let me just show you the language. 7, the inverse function passes through the points negative 1, 2, and 0, 4. Okay, so they're making us jump through one more hoop. The inverse passes through these 2 points. Now, if the inverse passes these 2 points, what about the function itself? Switch around the x and y. So that means f goes through 2, negative 1, and 4, 0, right? Okay, they said the inverse touches these 2 points. What's the property of the inverse? Switch around the x and y. So if negative 1, 2 is on the inverse, then 2, negative 1 is on the original function. 0, 4 is on the inverse, so 4, 0 is on the original function. Okay, then the rest is the same. It's exactly the same as this. So let's do it. So slope is y2 minus y1 divided by x2 minus x1. 0 minus a negative 1 divided by 4 minus 2. Change in y divided by change in x, or delta y over delta x. So that's 1/2. Okay, so then I'll use the point slope form. I think I like this point better. There's a 0 and there's no negatives. So y minus 0 equals m 1/2 x minus 4. Y equals f of x equals 1/2 x minus 2. Okay, pretty much it. Double check. The function should go through these 2 points. Plug in 2. Do you get -1? 1/2 of 2 is 1. 1 minus 2 is -1. That works. How about what do you get when you plug in 4? Half of 4, 2. 2 minus 2, 0. It works. So this has to be the right answer. Okay. All right, now let me go back and do 5. F of 1/2 is -3. That's a point. And the graph of f is a line parallel to the line x minus y equals 1. Okay, let me write down all that data. And we'll go from there. F of 1/2 is -3. That means the ordered pair it touches is that. And then it says parallel to x minus y equals 1. Okay. You might recall parallel lines have the same slope. So recall parallel lines have equal slope. So I just need to find the slope of this line. Once I have the slope of this line, I'll use the same slope for this line. Okay, how about I'll move the y over here and the 1 over here. X minus 1 equals y, or y equals x minus 1, right? Add y, subtract 1, looks like this. So that looks like y equals mx plus b. So what's the slope? What's the coefficient of x? 1. Okay, so I use this slope and I use this point. So y minus a minus 1, y minus a minus 3, sorry, equals m 1 times x minus x1, x minus 1/2. Okay, just clean that up a little. Y plus 3 equals, well, 1 times that is just that. That's 1/2. Subtract 3, subtract 3. So f of x is x minus 1/2 minus 3 is minus 3.5. I can say minus 3.5. Or f of x equals x minus 7 over 2. That would also work. Okay. So it's parallel to this. That means the slope is 1. Correct? Passes through 1/2 -3. What happens if I plug in 1/2? 1/2 minus 7/2 is -6 over 2. That's -3. So it works. All right. Then the last one I was going to do, and then I'll be done, okay, is 9. So I'll save the other ones for tomorrow, but it's not that easy. They're all word problems. Okay, so I'm saving all the word problems for tomorrow, basically. Okay, so the last one, which isn't a word problem, is 9. F of x is blah, blah, blah. G of x is blah, blah, blah. determine whether the function f circle g is linear. Okay, so I have to do the composition, f of g of x, and you're saying, is it linear or is it not linear? Okay, so how do we do that? So f of x, you tell me, is 3x minus 4. G of x is 1 minus 2x. So find the function number 9 there, f circle g, the one that looks like fog. And is it linear or not linear? Okay, so f circle g of x, that means f of g of x. Okay, so how does that work? Right here, I replace g of x with what is equal to 1 minus 2x. So f paren, leave that f alone, leave that left parenthesis alone, leave that right parenthesis alone. Inside, put what g of x is equal to, 1 minus 2x. And now this thing behind my finger goes right there in parentheses, right? So behind my finger was 7, I put 7. If it said a million, I put a million. If it said W, I put W. If it's a mess, I put the mess. So there's the mess, right? 3 times 1 minus 2x minus 4 is what I want. Okay, and I cleaned that up. So let's see, 3 minus 6x minus 4. So that's negative 6x minus 1. Is that right? Yeah. And yes, it's linear. How do I know it's linear? Linear functions look like mx plus b. This looks like mx plus b, right? The slope is negative 6, y-intercept is negative 1, so therefore it's linear. Okay, I'm done, folks. So I've done some of 4.1. All I have is the remainder, but the remainder is all word problems. So, you know, it's not as small as you might think. So if you look at 11, that's a word problem. 13 is a word problem. 15 is a word problem. Okay, so tomorrow is mostly going to be word problems, and then I'll give you the quiz on top of that. Okay, I'll check to see if anybody has any questions, and if not, I'll give you the in-class assignment, and we're done. Okay, so let's see. So anybody want to? Let's see. I don't see anything in the chat, and anybody else have anything? Okay, if not, then we'll go straight to it. Let's see. So 4.1 number 9 again. Okay, is this what you mean? If you just want to see it. Okay, so it's there, and you can watch the video later also. Okay, so I think that's that. Any other questions? You can unmute yourself or put it in the chat. Otherwise, I'll give you an in-class assignment and we're done. Okay, so here we go. You take a picture on your cell phone. Okay, I'm going to write it out for you. Okay. Let y equals f of x equal x minus 3 over 10. Find f inverse of x, and that's all you have to do. Okay, so write it down, take a screenshot, take a picture on your cell phone. I think for this one, I can even put it in the chat. Okay, so to find the inverse, switch around x and y, and then resolve for y, right? And for this time, you don't have to write the f to the minus. It's too hard to type that on your keyboard. I want you to write that on the quiz and homework and test, but not for today, not for right now. Okay, so the function is x minus 3 over 10. Come up with the inverse function. I'll hold this just for another 15 seconds. I'll also type it in the chat to help you. And when you're done, type it in the chat, and you can leave, and I'll see you tomorrow. Okay, I'm going to make it disappear. I will stop the share. And I'll stop recording also, by the way.